camera holder. Triple video recording in our new camera holder. 1, 2, 3. Okay, we should be recording 3. Let's put you in place. Okay, triple. Where we gotta put you? Where do you want to be? You want to be over there? We'll put you over here. Okay, we got 3 cameras rolling. How's the light? We don't know. The light could be pretty good. We don't know if we need that light. Could be bad for us. So we got a triple video recording. Yeah! We got a test. We're testing our video, triple video recording. So we have some sunlight coming in too. So we don't know what this light is going to do, you know, but it's diffuse. So the lighting could be pretty good, you know. So, Reductio ad Absurdum, you know, when the stuff's written in the textbooks, when it's taught by professors and when people get Nobel Prizes for it, it's hard to believe yourself that it's absurd. So the expanding universe is based on redshift, okay? Now, for some reason, you know, Hubble didn't agree to it. Hubble even apologized for using velocities. He explained that you read too much into the redshift if you think it's Doppler redshift. Okay? He believed that something other than Doppler caused the Hubble flow redshift, and that the redshift was an excellent instrument, a tool to calibrate distance. Not a perfect tool, but an excellent tool to calibrate how far away an object is. But it's not a perfect tool. Okay? The reason it's not a perfect tool is that there's this assumption that space is a vacuum and that the speed of light is constant in space. But space has different consistencies, and they know that different materials, light will travel differently in different materials. And they also know that the compression of the gravity causes a shift in space, okay? And if you consider space to be composed of WIMPs, weakly interacting particles, okay, dark matter, so space is full of dark matter, okay? And if you consider space to be full of dark matter, and gravity compresses this dark matter into a smaller space, then space actually shrinks. Matter shrinks space. Let's call it. Matter shrinks space. Okay, so the WIMPs are compressed by matter. Well, it's actually heating matter, not just matter. Matter that is heating up compresses space into a smaller volume. And that compression creates an inflow and creates gravity. So it's a compression, okay? The sun heats up, and in the process of heating up, implodes, net implodes dark matter, WIMPs, neutrinos, God particle ones, strand ones, implodes this dark matter into a smaller volume inside nucleons, and inside a smaller volume inside neutrinos and inside electrons. So space actually shrinks around matter that is heating up. Now, dark matter, which is on a magnification, okay? So dark matter magnifies the gravity not of mass, but of the sun. So if you have a furnace, and that furnace radiates heat, then that furnace is going to magnify the gravitational pull of the mass, so that it's not an inverse square relationship. So as we move farther away from the sun, the velocity of the planets do not drop off as the inverse square of the distance. So that tells us two things, that that there's additional gravity created from the heat of the sun. And we know this from bullet clusters, because what astrophysicists believe to be dark matter stays with the stars that are producing heat. So if you have a furnace, then the nucleon matter is heating up, and also the invisible dark matter is heating up. The two processes compress space, compress dark matter into a lower volume, and that lower volume draws smaller particles from higher pressure to the lower pressure of the sun and the lower pressure of the planets. So that's how gravity is created. There's a flow of particles in because the Earth compresses particles that make up space, compresses them into a smaller volume. Since they're in a smaller volume, then more are drawn in. There's a flow. There's a flow from higher pressure to the lower Aether pressure of a mass or of a star. There's a flow. And that flow creates gravity. And when you create gravity and heat up mass, you store anti-gravity. Okay? So you don't get something for nothing. Gravity is not free. Okay? Gravity, when you generate gravity, you heat up mass and you heat up neutrinos, WIMPs, you heat them up, you heat up all those sacks, you compress space inside of them, okay? And when that's, and if you break one of those sacks, then you get an explosion, okay? All that compressed particles explode out, and you get gamma rays and all sorts of stuff. Okay, so nucleons have this compressed stuff in it. Neutrinos have less of it. Electrons have less of it. Okay, so that's why energy is directly related to mass. So you physically compress something inside a nucleon sac. You physically compress it. You reduce the volume, and that sac is harder. That nucleon is hotter. It pulsates faster and it's hotter, okay? So that's how you get higher frequencies. You increase the pressure inside the nucleon sac, inside the electron sac, and that increases the rate of pulsation, and that creates gravity, okay, as long as it's heating up. Now, so in the process of generating gravity, you're storing anti-gravity. You're storing dark energy. So dark energy isn't just something that's just intrinsic to matter. It is intrinsic and it isn't intrinsic. It's just as intrinsic as gravity. Okay, you store dark energy by generating gravity and heating mass up, heating neutrino sacs up, heating God particles up, and then in reverse, when you cool, you store gravity. Okay. Now, the reason we have the CMBR, the reason that it's above absolute zero is because there is a lot of matter that is below absolute zero. And the reason we know this is because when gas is compressed, you compress like hydrogen gas, and then when it turns to a liquid at 20 degrees Kelvin, okay, that's a much lower temperature, and it is 830 times as dense, okay? So you drop the temperature by 300 Kelvin, and you increase the density by 800 times, okay? So each degree Kelvin increases density 3 times. It's 900 times, 830 times as dense, and it's 300 Kelvins drop, okay? Now, I use a 1-to-1 ratio, okay? So white dwarf matter is 200,000 times as dense as Earth matter, okay? So I say that it's minus 200,000 Kelvin, okay? Because it got compressed and heat was taken out of it. The only way you can compress it to that volume is to extract heat through the Siemens refrigeration process. That's where you compress the gas gets hot, you have a heat exchanger, you remove the BTUs, and then you decompress it and it gets cooler. Then you compress it again, it gets hot, then you take heat out of it, and and it gets cooler, and the process makes it cooler and denser, okay? So through compression, heat exchanger, decompression, the sun converts matter to white dwarf matter at 200,000 times the density of 200,000 times the density of Earth matter. Okay, so in the end, when our sun becomes a white dwarf, 200,000 masses of Earth are going to be compacted to the size of Earth. And I say that Kelvin is 200,000 is negative Kelvin because all that heat was taken out of it. You didn't lose it. it was removed and went into the furnace along with fusion to generate the sun's radiant heat. Okay? So the sun's radiant heat is partly generated through the cooling and the creation of the white dwarf remnant that we will see in about 5 billion years if we're around, or 7 billion years. Anyway, the white dwarf remnant is going to come out. We're going to see it eventually. And it's going to be 200,000 times as dense as the Earth. Okay? So to make it dense, you have to remove heat in order to compress it. Compression, heat exchanger, decompression, compression, heat compression, decompression. And that's the sun pulsates. And while it's pulsating, compression, decompression, heat exchanger, it's creating the white dwarf stuff. Now, at higher pressure, you get neutron, bigger stars, you get neutron stars. And at bigger sizes still, you get black holes. You get more neutronium at minus 80 billion Kelvin. Okay, so neutronium has a density of 80 billion Kelvin. minus 80 billion Kelvin. And if it's a 3-to-1, okay, if for each compaction, okay, now hydrogen is compacted 830 times to be a liquid and a solid. 830 times, okay, almost 900 times to be a solid. Okay, and that's just a drop of 300 Kelvin. Okay, so if we use the 1-to-3 ratio, then white dwarf matter is going to be minus 600,000 Kelvin. And neutronium is going to be minus 240,000 Kelvin. Okay, if that 1-to-3 ratio continues. And there's a lot of BTUs that comes out of that. So a lot of the heat that's in the sun, okay? So you got all these remnants, okay, that are below absolute zero. And when they heat up from the CMBR, and when they heat up like trillions and trillions and quadrillions, a quadrillion times a quadrillion years, okay? When they heat up, okay, that degenerated matter is going to come back to matter. It's going to come back to hydrogen. It's going to come back to helium. Okay, it's going to be regenerated. So those degenerated masses, the black holes, the neutron stars, the white dwarfs, the brown dwarfs, all those masses over trillions of years are regenerating matter. Okay, so our galaxies grow because their remnant stars, the remnants of the stars, okay, those remnants become helium again, and they become hydrogen again, okay? But it takes a long time to warm it up to absolute zero. But once you warm up a neutron star matter to absolute zero, then you have a neutron. Then you have a hydrogen atom, because the neutron, once it gets to absolute zero, will form a hydrogen atom. So all those neutron stars are slowly, over 100 with 100 zeros after it, they're slowly evaporating into hydrogen, okay? So our galaxy is growing because the neutron stars, which could be trillions, we could have trillions of neutron stars just in the Milky Way. We can't see them. They're invisible. And all those trillions of stars are making hydrogen, okay? Now you need an interaction with another galaxy, and then a bullet cluster or any type of interaction, like the Triangium galaxy interacted with Andromeda, and in that interaction, gas moves from around. Instead of being in a halo, it moves around. Like in a bullet cluster, the gas ends up in the tidal tail, and it cools. So the hot gas cools and ends up in the tidal tail of the galaxies in a bullet cluster. Well, that's the process by which galaxies grow, okay? So you have the neutron star in the end the neutron star in the end is going to create more hydrogen than was used to make it, okay? But it has to warm up. It has to warm up to absolute zero, and there'll be more hydrogen than the process started. That's how a galaxy grows. It makes a neutron star, and then that neutron star, when it gets regenerated from the CMBR or an energy from stars, okay, when it gets regenerated, you're going to have hydrogen, okay? So the Milky Way has several sources of hydrogen. It has hydrogen that comes in, like from the DiPole repeller, and it has hydrogen that is made from the trillions of white dwarfs, okay? Now, this is all based on the fact that the cosmos is ageless, okay? It's been around forever, okay? But it's not infinite. If there was an infinite amount of the strand ones, which I consider to be the building block of matter, you start with the strand ones, and then you make GP1s, which is a mass energy vessel. And then the GP1s grow to the size of neutrinos, which is another mass energy vessel. And then you grow to the size of electrons, which is another mass energy vessel. And then you go to the size of nucleons, which is another mass energy vessel, okay? So you have all these mass energy vessels, okay? And you can consider them as gaseous sacs, okay? So